Oh, hello Internet. I didn't see you there. It's amazing how you all fit in that 3-year-old cell phone. But since you're here, this is the 1-year anniversary of the Blondihacks YouTube channel. I posted my first video 1 year ago today, and in that time, it's grown from 0 to 18,000 subscribers, which I'm really excited about. It's more growth than I expected in the first year, and so I want to thank all of you who watch and like and subscribe and share and comment. All of that is the reason that we've had this growth. And I want to send a especially huge thanks out to my patrons. They are the ones really making this happen. You know, I do have ads on my videos, but it's really just so that YouTube will distribute them more. I don't get any meaningful revenue from the ads. It's really the patrons that are paying for all of this. So as a thank you to my patrons, I thought it would be fun to do a Q&A. So I had all of them submit questions, and I'm going to do my best to answer all of them right now. I did get a lot of similar questions on different topics, so I kind of picked a set of emblematic ones. So hopefully if you asked a question and I don't read it directly, that you'll still get the information you were hoping to hear. Viewer Chip asks, mostly I'm curious about how you got started. I got a lot of questions in this area. What's your background? How did you get into machining? That sort of thing. So I actually trained as a computer scientist, and my background is primarily in software engineering. And but I've always had a lifelong love of all things technical, and I spent a good portion of my childhood on our family farm, where we worked with machinery all the time, and I got into cars at a young age. My dad taught me all about cars, and you know, we worked on cars. I later got into racing cars. I did endurance racing for a few years. So just a love of all things mechanical and engineering, and I've always loved building things. And I think if you have a love of building things, sooner or later, I feel like you end up in machining, because machining is sort of kind of the highest art form of building things. I think it's, you know, kind of the basis of all of our civilization is precision manufacturing. So yeah, once I started watching YouTube videos about it, honestly, I got sucked into videos like Adam Booth's channel and Mr. Pete and you know, all the usual suspects, Keith Fenner, Keith Rucker, and you know, I spent a long time watching those videos and finally decided I really want to actually just try that stuff. And so I started reading books and watching lots of videos and studying and learning everything I could, and bought machines and started playing with them. And you know, a few years later, here we are. And I'm hoping to now kind of pass on some of that early beginner knowledge that you know, I was looking for when I started. Okay, so let's get to probably the #1 question that I get, and I'll read the version of it from viewer Andrew, who asks, what are the make and models of the various pieces of equipment that you have, the lathe, mill, vices, etc.? If you could go back and advise yourself about equipment, would you buy the same again? So obviously I get this question a lot. People watching my videos are, you know, interested in machining or new to machining, and they want to know what equipment they should buy. It's a big decision. I landed on Precision Matthews for both my lathe and my mill. So my lathe is a PM22V, and it is a 10-inch swing and a 22 inches between centers. I think this is an excellent machine overall for the price point. That price point thing is key, you know, in this range of hobby benchtop machines. You know, there are going to be limitations, but I think that the Precision Matthews take on this type of machine is quite good. This is in a lot of ways a typical Asian import machine. They're made in China, and there are many brands that use the same castings, and they all buy them from various factories in China, and some of the companies rework different aspects of them. Some companies just import them and repaint them. So there's a lot of variation in these machines that all look like they're the same machines that are just different colors. So you'll see this same machine from Grizzly and from various other sources, all different colors, but that doesn't mean they're the same machine. So you gotta kind of look at the details. So this won't be a full review of all my machines, because that would be a long video on its own, and I will do that video at some point, but a couple of the highlights, pros and cons. I'm not sponsored by Precision Matthews, and so I'm going to give you an honest assessment of this equipment. I've been very happy with the lathe in particular, and Precision Matthews as a company has been great to deal with. Their sales and support folks have answered a lot of my questions, and they're always there for you when you have questions. And I've found the machine machine to be very well made. The slides are all nice. The hand wheels all move nice. There are locks on everything. Some of these low-end mills, don't have a lock on the compound, or they don't have, some of those things. It is a DC lathe with a brushless DC motor, like a lot of these machines now are that are smaller, and that's great because it gives you this continuous real-time speed control. You can adjust your speed while you're facing, things like that. Very nice. It does have a quick change gearbox. It is fairly limited in that it gives you forward and reverse, which is nice. You can cut left-hand threads, for example. You can power feed in both directions. There are no threading settings on here. This is just for feed speed, so it gives you 3 feed speeds, which is nice. But when it comes time to start doing threading, you do have to get into the change gears. So if you're going to be doing a lot of single point threading, you might have to go to a bigger machine because this transmission does not have threading gears in it. I've had this machine for a few years now, and it's held up like a champ. The only kind of signs of aging or wear that I've seen on it is the gearbox struggles a little bit to get into the slow range sometimes. I have to fidget with it a bit. But other than that, it's been great. I have changed the oil on it once already, and it's probably due for another oil change. That is kind of a weak spot on this machine. The drain plugs for the gearbox in the carriage and on the quick change are kind of in silly places. I actually have a blog post about changing the oil in this guy, which I will link to down in the description. But otherwise, I have been very, very happy with this machine. Over to the mill now. This is my Precision Matthews PM25MV. This is the smallest mill that they make, and I've also been quite happy with it. I would say that the limitations of small mills are a lot higher than small lathes. Small lathes can be much more rigid and powerful than a small mill can be because it's much more of a complex architecture for the machine itself. So I think with a mill, you definitely want to get the largest one that you can possibly fit and afford in your shop. You will benefit a lot more from the increased horsepower and rigidity of a larger mill than you will with a lathe. You can get away with a smaller lathe, I think, than the mill. So again, this isn't a full review, but it's held up well. I guess my main complaints with it are mainly just complaints you would have for any small benchtop machine. It has low horsepower at low torque. It will run as slow as 50 RPM, but the torque at that RPM is very low. And the torque also dissipates at the high end, so it'll run as fast as 2000 RPM, but at that speed, there is very little torque, and so you really can't run carbide on this guy very effectively. The weakest aspect of this machine is, without a doubt, the power feed. This was an extra option, and this guy I have honestly not been very happy with. The mounting on it is kind of clunky. It blocks one end of your T-slots, so I have a couple of T-nuts that forever are trapped in here, and they live in here so that I have T-nuts on this side of the vise when I need them. So that's quite annoying. I have to fish them under the vise when needed. And the speed adjustment on this thing is really janky. It's very touchy. The speed jumps around a lot at the low end, and it almost doesn't go slow enough for what I would like. And it's also very, very noisy. And it has these big spur gears inside here that you can't disengage from the lead screw. So when you're cranking manually, it's very loud, and you're cranking these spur gears, and you're also kind of cranking against the resistance of those spur gears. So that's all quite annoying. And yeah, the whole thing honestly just doesn't have a quality feel to it. It's clunky and loud, and the speed is kind of inconsistent on it, and yeah, just generally annoying. So this is definitely the weak spot on this guy. But other than that, I think for the price point, this has been a great performer. Okay, viewer Anonymous asks, you've referred to your mill as one of lower horsepower. Tom Lipton has also said the same about his, which floored me. What's enough horsepower? How do you compensate for low horsepower? So let's talk a little bit about horsepower on these machines at the hobbyist scale. Now, I'm sure that when I say low horsepower, I'm talking about a very different scale than Tom Lipton is, but this is the scale that we're talking about for home hobbyist machines. They're generally rated in kilowatts, and so this is a 750 kilowatt motor, which is about 1 horsepower. And this is what's in both of the Precision Matthews machines that I have. I'm showing you the one on the mill because it's a lot easier to get to than the one on the lathe. But both of these machines are belt-driven, which I'm a big fan of. I really like belt-driven machine tools. They are a lot quieter, and it also gives you a safety valve. If you crash the head or otherwise jam something up, you've got a belt that can slip. With gearhead machines, you don't have that, so something is going to break if you jam it up. I haven't done that yet, but it's nice to have that out. And as you can see here, there's a 2-speed pulley, and the lathe has the same because there's 2 main ranges. It gives you, 50 to 1,000 RPM, and then 1,000 to 2,000 RPM. But honestly, I've never moved any of these belts. You just keep them in the low range because, as I said earlier, on the high ranges, they don't really have the torque remaining to do proper machining. So how much horsepower is enough? Well, there's never enough horsepower in anything in life, right? More is always better. So you want as much as you can get. You're going to be limited by the size of the machine. The nice thing about DC machine tools like these guys is that brushless DC motors get a lot more horsepower for their size. So in a motor of this footprint, you can get a full 750 kilowatts, which is much harder to get with an AC motor. And you also get the benefits of variable speed control and all those other things. There is a limit to how high you can go with brushless DC, which is why you don't see these motors on bigger machines. And for example, if you have an electric car, or electric locomotives, for example, they have AC motors in them, and they use great big inverters to convert the DC power source into AC, because AC motors can always generate more power ultimately than DC motors can, but for their size, DC motors, especially brushless DC, are very impressive for what they can do. Horsepower is a key element in how aggressive you can be with your feeds and speeds. It's going to be a factor in your depths of cut and how fast you can power feed and so on. But ultimately, I think rigidity of the machine is more of a limitation on all of those variables. So having horsepower that's a good fit to the rigidity of your machine is probably more important than having as much horsepower as possible. Because I could upgrade this guy, put some giant 3-phase motor on here, and increase the horsepower by a factor of 20, but the machine isn't rigid enough for the types of cuts that horsepower would enable anyway. So it's really more about having a good match between the two. Viewer Anonymous asks, what happened to the machinist relay? Well, the good news is it is still ongoing. It goes a little slower than I was hoping it would when I first started it. I titled it Machinist Relay 2019, which I now see was optimistic. It's probably never going to finish in a single year, so it may just be an ongoing thing. But all the participants in it are busy, and people are doing it out of the goodness of their hearts. Nobody's getting paid for this, so it's not a high priority for everyone who's involved, and it takes time to get things shipped, and takes time to produce the videos. So it is still going, but we'll just have to be patient with it. As of this recording, myself and Adam Booth have done our parts, and AVE is doing his parts right now, and who knows where it might go after that, although I have a few ideas, but no spoilers on that. So keep watching the playlist on this channel. The Machinist Relay playlist is the master source of that project, so you can keep an eye on that. Viewer David asks, what are some of your favorite handbooks, references, charts, tables, etc.? And related to that, viewer Trevor asks, are there good purchasing and training resources for newbie home shop machinists? I'm interested in finding a good example of a starter set of tools, a guide and source for materials, and training for those tools. So I think this is a great kind of category of questions. When you're getting started in this, where do you learn besides YouTube channels like this one? There are a lot of great books out there. I think they come in 2 basic categories. There's your references and your learning tools. So for the learning tools, I think you'll find a lot of good hobbyist books out there, like these guys, Metal Lathe for Home Machinists, the Modern Shop Practice series. There's also lots of great books on model engineering, building simple model steam engines, making small workshop tools. This is another series of books that come in all different flavors. So, poke around on Amazon, you'll find books like these. Now, the trick with these guys is a lot of them are reprints of very, very old books. So this guy, for example, is quite an old book. And so a lot of times the lessons in them will be referencing, old tooling or old types of lathes, or in many cases the project requires castings from some old company that you can't get anymore. So there's a little bit of gotcha around some of that kind of stuff. And also a lot of the model engineering books, if you're into that, come from the UK, where model engineering is the most popular. And so they may also reference plans, companies, parts, documents that are all from the UK, and you may have some trouble getting some of them if you are elsewhere in the world. Another great option is this guy right here, Machining Fundamentals. This is a trade school textbook, and because of that, it is very expensive. It is, there's a premium on academic textbooks, but it is a great resource for learning all sorts of machining operations. It covers lathe, it covers mill, it even covers laser and EDM and modern CNC stuff a little bit. So this is a great resource if your budget allows. And now on to the reference materials. Of course, the captain of them all is the Machinery's Handbook, and you need to have some version of this at some point. It's basically everything that humanity knows about mechanical engineering is somewhere in this book. The somewhere is the key. It can be a little challenging to find stuff. This is definitely not a learning resource. It's extremely dense and extremely technical. But if you need to know, the exact wire EDM feed speed for some obscure alloy of stainless steel, or the exact pitch diameter for some type of machinery from 1912, or any obscure fact that you might need to know about mechanical engineering, it will be in this book. This book is expensive, but you don't necessarily have to have the latest edition unless you're a modern CNC machinist doing this for a living. You probably don't need the latest edition. If, like a lot of home machinists and hobbyists, you are working on manual machines, you're using techniques that frankly haven't changed a whole lot in the last 100 years. So you can go on eBay and find a 12th edition or a 15th edition, or this is a 29th edition. You don't need the latest edition. The information is still good for the stuff that we're going to be doing in the home shop. Now, this book is a little intense, and it can be a bit of an ogre for a lot of the really common stuff that you want to look up, feeds and speeds and common thread pitches and things like that. So for that more common stuff, something like this guy, the Engineer's Black Book, is a great option. It's got the 100 most common things you need to know in a much more easy to digest package. It's got lots of great tables and charts and all sorts of things in here. And so I keep this guy handy in the workbench. And this guy's also less expensive, so you don't have to worry too much about getting it greasy. I don't necessarily like having the Machinery's Handbook in my shop because the pages are delicate and it's expensive. So yeah, this guy is a great alternative for the quick stuff. And this comes in UK and American editions. The US edition has metric and imperial stuff in it, and it also has all the British stuff in it. So it's got your Whitworth and your British threads and so on are all in here as well. So this guy is a really great option. And I also use a lot of online charts and tables. If you've watched my videos, you've seen me refer to charts printed on my walls a lot. And those charts pretty much all come from littlemachineshop.com, which is a great resource for buying tooling and so on for hobbyists. And they also have a great section on their website with charts and tables and online calculators for different things, bolt circles and all sorts of different online calculators. And the nice thing about Little Machine Shop's tables is that they are calibrated for small hobbyist machinery, because that's who their customer base is. If you're looking online at, for example, speeds and feeds charts, you'll often find charts that are designed for, actual production machinists doing real work on real machinery. And so they're going to have like aggressive feeds and speeds that are designed for carbide and maximum production. And those aren't necessarily the speeds and feeds that you're going to want in your little hobby shop with your 3/4 horsepower machines. So keep that in mind when you're looking up charts. Consider the source. And I find littlemachineshop.com is a great resource. Oh, the fire went out. And if you want some real-time questions answered, a great resource for that is the forum at the Home Shop Machinist website. And I'll put a link to them down there in the description. They bill themselves as the friendly machining community, and I think that's a well-earned title. They're really open to new folks and people who might have, stupid questions that everybody knows. So I found it to be a very open and supportive community. I've had a few people ask about the benches that my machines are sitting on, so here's a look at those. This is a bench that I built myself, and I have a blog post about this, which I'll link to in the description. So it's all steel, made from 2-inch square tubing, and it's, I believe, 3/16 wall, fairly heavy. The whole bench, I think, weighs about 500 pounds, and it's got leveling feet on it, and it is L-shaped, as you can see, and the short section here separates from the main section, and it's actually hanging from the edge of the main bench there, and that allows me to adjust the height of that end of the bench, and then there's also a leveling foot down here so that the L-shape section is separately levelable, because of course, you know, the concrete floor is sloped for drainage, and so with an L-shaped bench you need to be able to differentially level both of these sections. So that's how that all works. And these benches were very much built with storage in mind, because I have a very small shop. What you're seeing here is basically the entire shop, and so I've made it with room for bins here, and this L-shaped section of the bench goes over this cabinet here, which is on wheels, and this cabinet actually pulls out for additional work surface. And so that's, you know, all of my tooling and so on is stored in there. And I've also got storage above my machines. So space is at a premium in my tiny little shop, and so I've tried to use every cubic inch of it that I can. Viewer John asks, I'd like to know what CAD software you are using. That's an easy one. I'm using Fusion 360. I'm a huge fan of Fusion 360, and I've actually written a blog post about the basics of it, which I will link to down in the description as well. What's great about Fusion is that it's a new product, relatively speaking, and so it has taken all of the learnings over the last 30 years in CAD software and UX and UI design. And coming from a software engineering background, you know, I appreciate the effort that they've put into that. You can really see the effort there, and so it has a much shallower learning curve than something like AutoCAD or SolidWorks, which are incredibly powerful tools, but they are expensive and difficult to learn. Pro Engineer is another common professional option. So Fusion has, I would say, 90% of the features of the high-end professional packages, but with a much easier learning curve. And they do have a free option for startup companies and students and various other categories. You have to dig around a little bit on their website to find the links to the free version, and it changes, so I can't really link you to it, but dig around a bit and you'll find it, and you have to click through on a form that says, yes, I'm a small company, or I make less than X dollars a year with this product, and so on. So there are a few hoops to jump through to get the free version, but there is a free version, and you can get started on it. The best way to learn Fusion 360 is really with the tutorials on their website. They have a series of video tutorials that are outstanding. They'll get you up and running with the basics in no time. You'll be modeling and cranking out engineering drawings for your parts in no time at all. And they also have written versions of all the same tutorials, which is super handy, because then you can search, and sometimes, you know, reading something is a lot faster than watching a video to get the information that you want. So can't recommend Fusion 360 enough. And viewer Glenn asks, every YouTube machinist seems to have a surface plate, generally made of granite. I know the general why, but not any details: thickness, heavy, precision, mounting, care and feeding, etc. So I will have a video specifically on surface plates coming up, but I thought I'd give you a look at mine, and I can talk briefly about it. They are generally made of granite, because granite is very stable and doesn't flex or shift a lot with temperature change, and it's also a material that's relatively easy to get a good surface finish on, and to get it very flat. These guys come with different ratings, AA and so on, for what the actual flatness is over its entire surface. But unless you're doing, really high-end precision work professionally, a lot of that isn't going to matter very much. This is a very basic surface plate from Little Machine Shop, and it was not expensive, and it's more than enough precision for anything that we're going to do here in the home hobby shop. And like with most things in life, bigger is always nicer. The thicker it is, the more stable it is, and the more it will hold its flatness over time. But once again, this is one of those areas where the low end of the market is actually very good, and so an inexpensive import granite surface plate like this is actually really quite good. Now, if you're buying one of these, it is a good idea to buy it locally if you can, because the thing about them is, well, they are extremely, extremely heavy. Like I actually can't lift that guy with my fingertips. Even this little small one. I mean, this guy is only like 8 by 12, but it is unbelievably heavy. And so I wouldn't want to have to ship one of these guys. So buy it locally if you can. And the general why for anyone who's interested, surface plates are basically your fundamental reference surface in the machine shop. It's basically the flattest thing in the universe as far as your machine is concerned. So anytime you need to measure the flatness or check the flatness or squareness of anything, all of the indicator tools and measurement tools that we use are all just relative tools. They measure how flat the thing is relative to something else. And so the something else is your surface plate. When you need to know how flat or square something is, you can put an indicator on the thing and the indicator rides on the surface plate. So this is how you transfer flatness from one area to another in your machine shop. All flat surfaces are ultimately referenced back to some surface plate somewhere in the world. And for all the rest of the details, I think you'll just have to stay tuned for my video all about surface plates. Viewer Kelvin asks, the picture of the cat that occasionally blinks onto the screen. What is the criteria for the appearance of that cat, and what's that all about? Well, so that is Sprocket HG Shop Cat. She is the shop manager here at Blondihacks, and she has a lot to say. She has a lot of opinions on the world, and so I've long since given up trying to keep her quiet or keep her from interfering with my voiceover recording and my filming when I'm doing that. So I've decided instead to just include her in the production, and every time she comments in the background, you will see her appear on screen. And I try to incorporate her into my projects where possible because the internet loves cats, and I mean, she's adorable. Now let's talk a little bit about the tool post. Viewer Mark asks, but what is the proper angle of the cutter to the work? Is there any sort of universal rule? And there are tons of videos, including mine upcoming, on the grinding of the various clearance angles on a tool bit, but you don't hear a lot of talk about the angle of the tool post itself. The general rule of thumb there is very simple. The angle of the tool post is just there to help you make sure that none of the sides of the tool bit are rubbing on the work. You want only the point of the tool bit, which is doing the cutting, to be touching the surface of your part. And that's really all that the tool post angle does in general. Now there are some other subtleties there. For example, you may have to square up the tool post if you need room for a tailstock fixture in here, like a live center that takes up more space. So there are some kind of housekeeping things you do with tool post angle, but in general it's not very critical. You're just kind of eyeballing it and making sure that only the part of the tool bit that you want touching is in fact touching. There are some other little tricks you can do with tool post angle. For example, if you have a tool bit like this that's ground square on the leading edge, when you put this guy in the tool post, you can angle the tool post back a little bit, and that'll give you some lead angle on a tool bit like this, and lead angle can help improve surface finishes. But in general, tool post angle is just about making sure that you have clearances on the sides of your tool bit and that everything is going to physically clear, when the chuck is spinning and when your tailstock is installed. And there's a lot of moving parts in here, and you don't want any of them to hit each other. So tool post angle gives you options for arranging all of the parts in here to make sure that you can get that tool bit in where you need to go and nothing's going to hit anything. Viewer Amar asks, I think that the lathe series is missing a video about threading, both internal and external. And also I'd like to know more about oils and fluids and those types of things for maintenance of the tailstock and so on. Great question, and the good news is I actually have upcoming videos on all of those topics. There is one on threading that is in the pipeline, and also one about machining fluids in general. There's a lot of oils and other fluids involved in machine shop work, and so I'll be talking about all of that in upcoming videos. One other quick question I can address, since I get asked a lot in the comments, is where did I get this apron? This apron is from moonshineleather.com, and you can go there and get one yourself. I'm hashtag not sponsored, but this was a gift, and I really, really love it. So you can go and get yourself one over there at Moonshine Leather. So thank you all very much for a great first year, and especially thanks to my patrons who are keeping Sprocket here in kibbles and toys. She's very high demand in the toy department, so that's much appreciated. And here's to an even better year 2. Thanks very much for watching, and we'll see you next time.